Welcome to the Complete Power BI Interview Questions Guide for Microsoft Business Intelligence. Power BI has become the leading business analytics tool, essential for data analysts, business intelligence developers, and professionals working with data-driven insights. This comprehensive tutorial will cover everything you need to master DAX formulas, data modeling techniques, report creation processes, and enterprise analytics solutions. Whether you're preparing for your first Power BI interview or advancing your career in business intelligence, this guide provides the essential knowledge and practical examples that employers are looking for. Power BI can connect to a wide variety of data sources, making it incredibly versatile for business analytics. Common data sources include Excel files, CSV files, SQL Server databases, Azure services, SharePoint lists, and web sources. The connection process is straightforward. First, click the Get Data button from the Home ribbon in Power BI Desktop. Then select your specific data source type from the available options. Next, provide the necessary connection details such as server names, file paths, or authentication credentials. After that, navigate through and select the specific tables or data you need. Finally, choose to either load the data directly or transform it using Power Query Editor for cleaning and preparation. Data modeling is the foundation of effective Power BI solutions. The star schema design is the recommended approach, featuring a central fact table surrounded by dimension tables connected through one-to-many relationships. Fact tables store measurable data and metrics like sales amounts, quantities, or transaction counts. Dimension tables contain descriptive attributes such as product names, customer details, dates, and locations. Relationships connect these tables using foreign keys, enabling efficient data retrieval and analysis. This design pattern optimizes query performance by reducing complexity and ensuring fast report rendering. Proper data modeling also supports intuitive navigation and maintains data integrity across your entire business intelligence solution. DAX stands for Data Analysis Expressions and is the powerful formula language used in Power BI for creating custom calculations. Similar to Excel formulas, but much more sophisticated, DAX works specifically with relational data models and provides context-aware calculations that adapt to filters and user interactions. DAX consists of two main components: calculated columns and measures. Calculated columns are added to existing tables and computed row by row when data is loaded. Measures, on the other hand, are dynamic calculations that aggregate data based on the current filter context. DAX supports complex business logic, handles time intelligence scenarios, and works seamlessly with Power BI's columnar database engine for optimal performance. Understanding essential DAX functions is crucial for Power BI success. Aggregation functions include sum for calculating totals of numeric columns, average for arithmetic means, count and COUNTA for counting non-blank values, and max and min for finding extreme values in datasets. Logical and filter functions provide advanced capabilities. The IF function enables conditional logic with different outcomes based on specified criteria. Calculate modifies filter context for specific conditions, allowing you to create sophisticated measures. The filter function returns filtered tables based on custom conditions, essential for creating dynamic calculations that respond to user selections and report interactions. Advanced DAX techniques involve understanding filter context and time intelligence functions. Filter context determines which rows are included in calculations based on applied filters, slicers, and visual interactions. The calculate function modifies this context for specific conditions. The all function removes filters from specified columns, while ALLEXCPT removes all filters except those specified. Time intelligence functions enable powerful date-based calculations. SAMEPERIODLASTYAR returns dates from the same period in the previous year. DATESYTD provides year-to-date calculations from the start of the fiscal year. DATEADD shifts dates by specified intervals like months, quarters, or years, enabling flexible time-based comparisons and trend analysis. Power Query Editor is Power BI's built-in extract, transform, and load tool for cleaning and shaping data before analysis. Access it through the Transform Data button in Power BI Desktop. Power Query provides comprehensive data cleaning capabilities, including removing duplicates, handling missing values, and standardizing data formats. Data shaping operations include pivoting and unpivoting tables, merging data from multiple sources, and creating custom columns with calculated values. The applied steps feature records and replays all transformation operations, ensuring reproducible data preparation processes. For advanced scenarios, the M formula language enables custom transformations and complex data manipulation beyond the standard user interface options. Power BI offers diverse visualization options for different analytical needs. Bar and column charts effectively compare categories and values across different groups. Line charts excel at showing trends and changes over time periods. Pie charts display parts of a whole, though they work best with limited categories. Maps provide geographic data visualization for location-based insights. Tables and matrix visuals present detailed data in structured formats. Gauge charts track key performance indicators against targets, while cards highlight single important values. When creating visuals, choose the right chart type for your data story, keep designs simple and uncluttered, use consistent color schemes, provide clear labels and titles, optimize for performance by limiting data points, and ensure mobile-friendly responsive designs. Understanding the distinction between reports and dashboards is essential for Power BI success. Reports are comprehensive, multi-page documents with detailed data analysis capabilities. They support drill-down functionality, interactive exploration, and mobile-optimized layouts. Reports are created and designed in Power BI Desktop, offering full development capabilities with complex visualizations and sophisticated data models. Dashboards, conversely, are single-page overviews designed for at-a-glance insights and key performance indicators. They highlight the most important metrics and provide quick summaries of business performance. Dashboards are created in the Power BI service by pinning tiles from reports or connecting directly to data sources, focusing on executive-level visibility and real-time monitoring. Power BI provides enterprise-grade security features to protect sensitive business data. Row-level security, known as RLS, controls data access at the individual row level based on user roles and permissions. Multi-factor authentication integrates with Azure Active Directory for enhanced login security. Data encryption protects information both at rest in storage and in transit during transmission. Audit logs track user activities and system changes for compliance and monitoring purposes. Administration capabilities include workspace management for controlling access and collaboration settings. Usage analytics monitor adoption rates and performance metrics across the organization. Tenant settings configure organizational policies and feature availability, while data gateways provide secure connections to on-premises data sources. Optimizing Power BI performance requires attention to both data modeling and report design. Data model optimization starts with implementing star schema design using fact and dimension tables. Remove unused columns during data import to reduce model size and memory consumption. Choose appropriate data types to minimize storage requirements. Avoid bidirectional relationships when possible, as they can impact query performance. Replace auto-generated date tables with custom ones for better control and efficiency. Report performance optimization involves limiting visuals to 6 to 8 per page to ensure fast loading. Optimize DAX formulas using efficient patterns and avoiding overly complex calculations. Use aggregations for large datasets to pre-summarize data. Implement incremental refresh to load only new or changed data, and reduce unnecessary visual interactions between charts to minimize cross-filtering overhead. Real-world interview scenarios test your practical power by knowledge and problem-solving abilities. A common question asks how you would create a sales dashboard showing year-over-year growth by region. This requires star schema design skills, time intelligence functions, DAX calculations for growth metrics, and geographic visualizations with appropriate drill-down capabilities. Performance troubleshooting scenarios ask what steps you would take when reports load slowly. Solutions include data model optimization, improving DAX efficiency, limiting visual complexity, and implementing query folding techniques. Security implementation questions focus on row-level security for multi-tenant applications, requiring knowledge of RLS setup, security roles, dynamic security patterns, and user context management. Data connectivity questions explore the differences between import mode for cache data, direct query for real-time connections, and live connection for direct server queries, each with specific performance implications and use cases.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.